by its lonesome. You cannot put it into a larger group. Everybody okay with that? Yeah. All right. Did that help me out? Now I can do what? Group of 4, right? And then a single one term. So that's nice. Help me out?
Because it's still one off.
Okay. How many no's? How many don't knows? I hurt myself here. In terms of, here I've got what? Group of 4. Can I put this into a group of 2?
No.
Can I put that into a group of 2?
No.
No. Cannot. Okay. Everybody all right with that? How about if I do this? Now, I could take this guy and put it into a group of 2. This one and this one here. Now, that still leaves me this guy to cover, but I could stick it into what? Into a group of 2 here. So, what happens if I do that? Now we're in good shape, right? Now we have 2 groups of 4. A group of 4 here, and then these corner guys, remember, because things wrap around, we could stick those into a single group of 4. Question? So if I had just that, assume for the time being that everybody else is zeros, what would be the minimum sum of product solution for this map? Okay, let's do the inner 4 first. Is the A variable changing? Don't include it. Is the B variable changing? Does not, so we're going to have to include it, correct? Do we want a B or a B bar?
B.
All right, looking here now, what variable is changing?
C.
So we're not going to include it. Is D changing?
No.
So when we include it, do we need a D or a D bar?
D.
That handles that inner group of 4. Now the corners are going to be what? All right, so as we look at this, what variable is changing? A. Don't include it. How about the B? It is?
B bar.
It's not changing, but we need a B bar. All right. How about going down here now? What variable is changing?
C.
But D bar we need. So that would be our minimum sum of product solution for that guy there. In terms of gates, we would need what? 2 NOT gates, 2 AND gates, and an OR gate. Everybody okay? Stop there. Okay, how many variables? 5. So how many cells are you going to have?
32.
32. How are you going to make a 32 cell map? Well, what we're going to do is we're going to make 2 16s. So I'm going to put this is going to be, that group is going to be for E equal to 0. And so we'll do 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1. Now I'm going to put under it, and you can think of these things as on top of one another. So now we're going to do a group of 16 for E equal to 1. So I'll let you finish that up. Question?
So does that mean that the bottom squares on the top one would match up with the top squares on the bottom when it wouldn't cross over to the top anymore?
You have to think of them as being sandwiched one on top of the other.
Okay.
Is that okay? So
Line flat on top of one another, not like up and down.
that is correct. You take them, tip them over, and you're going to stack them up like a sandwich. This may get a tad bit confusing, but I'm going to start numbering these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 24, 26, 27, 28, 30, 31, 32. Amazing number. Okay, so just as before, we're going to put in ones here to implement our function. Let's do the last term first. Which one of those 32, because I've got all 5 terms, right? Which one of those 32 am I going to put a 1 in? You're going to do it the top one or the bottom one? Why the top?
Because
Because it's an E bar, correct? Okay, so we're up here now. Now, we need what? A is a 0, B's a 1, C's a 0, so that's one of these two guys here, correct? And D, excuse me, I'm sorry, here. One of these two guys, and then D is a, so which one are we gonna light up? 6. Everybody okay with that? Yes? All right, so let's take a look at this guy here now, A, B, C. So we're going to have how many 1s due to this term here?
2.
I don't like 2.
4.
I like 4. We're going to have 4 terms. Okay. So, does it matter what E is doing? So we're going to put 1s in top and bottom. Does it matter what D is doing? No. Okay, so let's go through here. A and B are 1, so we've got along these 2 rows here, and C is a 1. So I'm going to put a 1 there, a 1 there, and a 1 there, and a 1 there.
So would that make that a group of 4
Yes,
on top of one another?
exactly. They're on top. See, you can think of it now is that it's a group of 4 because they're on top of one another. And I can get from here to here by only having one variable change. Can I get from here to here by having only one variable change?
No.
No, but I can get there via a path where only one variable is changing. Is that okay with everyone? All right, the next one is AD and E. So I'm again going to have how many 1s? 4 of them. Are they going to be at the top or the bottom or a mix? Bottom. All right. So A is a 1, so we're somewhere in here. D is a 1. D is a 1 here, right? So we're going to put in those there. Doing all right with everything? Now, what about our minimum sum of products solution?
We do one group of four, two groups of two, and one group of
Two groups of four. Where's the group of two?
That you did in 2020, 2022.
Let's, okay, so you could, we just did that, we can do that in group four, correct? And that gives me that one, but can I stick it into a larger group?
Yes.
This guy, these guys here, right? So you would indicate that like so, because they're on top of one another. Well, that just gives me this guy here. And then I got one more one to cover, and that's this guy here. Can I stick it into a larger group? The answer is no. So this guy here is the minimum sum of product solution. All right.
So if we're doing groups across the two boards, the groups have to be in the same location.
Yeah, they have to be on, like on top of one another. So how many variables do you think you can handle with this mapping technique? You just handled how many? 5. 8.
I feel like much more, any more than this is like,
You can do 6. With 6, you're going to need how many 4 variable maps? 4. So you would do something like this. And over that, you don't want to mess with. But there are computer programs out that can do this kind of stuff for you. You have multiple variables like that. But 6 is about the most you can tackle with this technique. All right? Okay, if I had a 1 here, would that have helped me out?
Yes.
Yeah, because then I could have taken this guy and done what? Put it into a group of 2. And for that group of 2, I'd have how many variables?
2.
I know we'd eventually count that high. Yes, 4 variables, right? Okay. So how many variables did it take to do 4 ones? 3 of them. If I had 8 ones that were all in a group, I'd have to do how many variables to make it? 2. If I had 16, I would need 1. Is that all right with everyone to understand what's going on? Okay, so here I'm going to have a function, and it's going to have some don't cares. So I'm going to have a 0, 1, 0, 1, x, x, x. The possibility of having a 1 for a 0, 0 for B and C, impossible. cannot ever have that particular combination of inputs. Same way it's impossible to have a 1, 0, 1, it's impossible to have all the variables 1 at the same time. Who knows what physical constraints would make that happen, such that you could never have those combinations for the inputs. So we put an X there, and we don't care whether we say we have a 0 or a 1 there, because that combination will never happen. So could I exchange an X for a 1 or a 0 and help myself out?
Yes.
Yes. Okay. So what would I want to, would I want to change this guy here?
No.
Remember, my object is to cover the 1s. Okay, so let's start with the 1s here. Can I put this into a larger group? Not by itself, but if I do what? I can't. If I make this guy a 1, I can take that guy there and put it into a larger group. And so my F there would be what? B bar C. Everybody okay with that? What variable did not change? What variable does change? A. So we don't include it. What variables do not change? B and C, but I need the B bar. I got this one to cover. Can I stick it into a larger group? Yes. There, right? And so to cover that, it would be what? B, C bar. Okay, so to help myself out, I would say that's a 0, that's a 0, that's a 1. Everybody understand what's going on there? You can use those don't cares to help you make a smaller minimum sum of products.
What if you wanted a group of 4 across the bottom? Would this be all?
Oh, if I wanted, if this was a don't care?
No, if all 3 are all 1s, all X's.
Oh, if these were all
That would be a
ones,
group of 4.
it doesn't help you out.
Okay.
Because if you made those all ones, how would you have to cover that now? See, I'd still do this guy, these two guys here, still these guys, but then to put that there, then I need another term, A, which that makes a more complicated function. So you would not do that. Yeah.
So if we make that a 1 to simplify the equation, how would a computer know that it's not possible?
It's not possible because it's physically impossible to put the inputs in there.
Oh.
It would still think, oh, if those particular inputs come in, I know what to do with them. It's just that I'm not good. Something physically is going to keep that combination of inputs from happening. Remember, I used the idea of the 13th floor, on an elevator. There isn't one. So, doing all right?
Why isn't there a 13th floor?
Unlucky.
At Mayo this summer, they didn't have 11 floors in a couple of the buildings because historically that number is unlucky for them.
Oh,
Yeah.
really?
Yeah.
So they just make the floor, but they just skip it?
They just skip it.
I've never noticed that. That really bothers me that I've never noticed it. I'm unobservant. What? In New York.
So any questions on Carnot maps or why we want to use them?
So